AP Stats, we're back at it. We're going to do a little warm up here. Here's the game. If the player rolls 2 dice and gets a sum of 2 or 12, he wins $20. If the person gets 7, he wins $5. The cost to play the game is $3. Find the expected payout for the game. Pause it, see if you can figure this out by yourself. If you can't, I'm going to do it with you right now. Whenever you're dealing with dice, guys, and you're dealing with 2 dice, make a little grid just like we have right here. Here's all the possible numbers we could get with 1 dice and with the second one. I don't like to say die. I know that's like the singular term. I just don't like that word. I'm trying to stay positive, people. Okay. So what can happen? Well, we don't have a distribution, so we have to set up a distribution just like we looked at on video number 2. Okay. Find the expected payout. So how much are we going to win, right? So here's how much we could win, and here's the probability of winning, okay? Now it says if we get a sum of 2 or 12, we can win $20, okay? Well, now we need to figure out the probability of getting a 2 or a 12. So in here, you guys, this is my sample space. So for example, I could get a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, so on and so forth. I could get a 2 and a 1, a 2 and a 2, a 2 and a 3. I want to know where is every place on this board where I could get a sum of 2 or a sum of 12. So I could get a sum of 2 of right here. 1, if I rolled a 1 and a 1, that would give me a sum of 2 right here, or a sum of 12. To get a sum of 12, I would have to roll a 6 and a 6. There's 2 places that I could get a sum of 2 or 12. There's 36 places total, right? So I'm going to put 2 out of 36. Okay. Next, if a person gets a 7, he wins $5. Okay. Oops, I was going to put 7 there. My bad. So now we have to think where are all the places we could get a sum of a 7, right? So we could get a sum of a 7 right here, a 6 and a 1, a 5 and a 2, a 4 and a 3, a 3 and a 4, a 2 and a 5, or a 1 and a 6. There are 6 different ways out of 36 total possibilities that we could get a sum of 7, which would make us win $5. Finally, remember your probability distribution has to add up to 1. That means what's left over? What about all these spots we have not marked, right? What if we roll these spots? What would happen then? Well, we win nothing, right? How many places are there where we're going to roll nothing? Okay, so we're going to do 36 minus 8. So 36 minus 8 is 28. There are 28. If I did all these red X's, I would get 28 of them. I know it doesn't look like it, but we would, right? Because we already have 6, 7, 8. We need 28 more for a total of 36. 28 out of 36. Okay, I'm going to pull up my calculator. I'm going to just do this one by hand. This one's an easy expected. Okay, so it says find the expected payout, the expected winnings. So what I'm going to do right now, ladies and gentlemen, is I'm going to just quickly type this out. And it's not a bad one. So the expected winnings, right, is 20 times 2 divided by 36 plus 5 times 6 divided by 36 plus 0, right, times 28 divided by 36. Well, we know this one right here is 0. So instead of putting in L1 and L2 and taking that much time, what I'm going to do right now is I'm just going to take 20 divided by, or times 2 over 36 plus 5 times 6 over 36. and I get 1.944. That's my expected winnings. Is the game fair? Why or why not? So this is saying over time, if you play this game over and over and over again, you should expect to win $1.94. But guess what? It costs $3 to win the game. So what's actually happening, ladies and gentlemen? We're actually losing money, right? We're losing money. If we take $1.94 and we minus $3 from it, right? Because that's how much we paid for the game. We're actually losing in the long run $1 and about 6 cents, okay? That's how much we're losing in the long run. Okay. So how much would you pay to play the game? Well, if the expected winnings is about $1.94, I would pay no more than $1.94. That means I'm going to be breaking even in the long run. I'd want to probably pay like 10 cents, but in the long run, we would be breaking even. Okay. All right. I'm going to put this in as a video as a little warm up. Check your understanding. Is the game fair? Because this is a common question on the AP test. And then we're going to move on to transforming variables with